Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of lateral surfaces of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a regular pentagonal prism of base edge 40 mm and axis height 75 mm. Now this regular pentagonal prism, it is kept onto the ground on its base with one of its rectangular faces away from the observer and parallel to vertical plane. So if we choose this orientation of the pentagonal prism onto the horizontal plane, now we will observe that none of the base edges, they will be parallel to the vertical plane and away from the observer over here. So this orientation of the pentagonal prism with respect to the two reference planes happens to be incorrect. Whereas if we are going to place the prism onto the horizontal plane into this orientation, now we observe that one of the vertical faces, that is 4-1, 4-3 and 3-1, it will be parallel to the vertical plane over here, and this face will be away from the observer. This orientation of the pentagonal prism, it is the correct orientation with respect to the two reference planes over here. So now we have been provided with the information that this pentagonal prism has been cut by an auxiliary inclined plane which happens to be inclined at an angle of 45 degree to the horizontal plane and perpendicular to the vertical plane, bisecting the axis over here. Therefore, this AIP passes through the midpoint of the axis of the pentagonal prism. So with this information, we are required to obtain the development of the lateral surface of the truncated prism. So let us now evaluate orthographic top view and the front view projections corresponding to this pentagonal prism. So as the observer is going to look at this pentagonal prism from the top, we are going to obtain the pentagonal projections onto the horizontal plane over here into the top view projections. So here we can check the edge of this pentagonal prism happens to be 40 mm. So with base edge 40 mm, we have been able to obtain the pentagonal construction onto the horizontal plane. So the 5 points of the base 1, 2, 3, 4 and 5, they have been marked on the inner side of the pentagonal construction over here, whereas the 5 points corresponding to the top face of the pentagonal prism, they have been marked as 1 1, 2 1, 3 1, 4 1 and 5 1. So these 5 points, they have been marked outside the pentagonal construction which has been obtained into the top view projections. So now we have to evaluate the axis corresponding to this pentagonal prism. So in order to evaluate the axis of the pentagonal prism, we need to draw perpendicular bisectors from each one of the 5 corners of the base onto the opposite edge of this particular pentagonal prism. So from point 1, we have drawn perpendicular bisector of the edge 3, 4. From point 2, we have drawn perpendicular bisector of the edge 4, 5. Similarly, from the corner point 3 of the base of this pentagonal prism, we have drawn perpendicular bisector of the edge 1, 5 over here. Similarly, from the base corner point 4, we have obtained the perpendicular bisector of the edge 1, 2 over here. And from the point 5, we have obtained the perpendicular bisector of the base edge 2, 3. Now, wherever these 5 perpendicular bisectors from the 5 corner points of the base, they are going to intersect with each other, we are going to obtain the axis points O and O1 over here. Whereas point O, it is the axis point corresponding to the top face of the pentagonal prism. O1 represents the axis point corresponding to the base of the pentagonal prism. So once we have obtained the top view projections of the pentagonal prism, let us proceed to evaluate the front view elevation projections corresponding to this pentagonal prism. So we know that height of the axis of the pentagonal prism happens to be 75 millimeter. So now once we mark axis height or the height of the pentagonal prism as 75 millimeter, so we need to draw projectors from the 5 base points and projectors from the 5 top face points into the elevation projection view. Now once we draw perpendicular projectors from the 5 points of the top face, that is 1 1, 2 1, 3 1, 4 1 and 5 1 into the elevation projection view, then we observe that at a height of 75 millimeter above the XY reference line, we have been able to obtain elevation projections corresponding to these 5 points of the top face. Now we are able to obtain the projections of 5 points of the base into the elevation projection view and 5 points of the top face into the elevation projection view at a height of 75 millimeter from the XY reference line. Now one thing we need to understand over here, that the vertical edges 1 1 and 1, 2 1 and 2, 3 1 and 3. So these 3 vertical edges of the pentagonal prism, they are visible to the observer, as the observer is going to look at this pentagonal prism from this side, that is from the front side. So the projections corresponding to these vertical edges, that is 1 1 dash and 1 dash, 2 1 dash and 2 dash, 3 1 dash and 3 dash, they will be observed as object line projections over here. Whereas the vertical edges 5 1 5, 4 1 4. So these 2 vertical edges of the pentagonal prism, they happen to lie on the rear side of the solid over here, as the observer is going to view this solid from the front side. So these 2 vertical edges 5 1 5 and 4 1 4, they will not be visible to the observer. Therefore, the front view projections 5 1 dash 5 dash and 4 1 dash 4 dash corresponding to these 2 vertical edges, they will be obtained as hidden line or the dotted line projections into the elevation projection view. Let us now proceed to obtain the development of the lateral surface of this uncut pentagonal prism over here. So now we are going to make use of parallel line development method in order to obtain the development of the lateral surface of the uncut pentagonal prism over here. So now we have drawn a horizontal projector line through the top face of this pentagonal prism. Another horizontal projector line we have drawn through the base of this pentagonal prism over here. Now the distance between these 2 horizontal projector lines, it provides us with the true length of the vertical edges of this particular pentagonal prism. So now let us start with point 1 1 and 1 over here. That is, we are going to start the development of this pentagonal prism starting from the point 1 1 and 1 over here. So now we know the edge length. Edge length happens to be 40 millimeter. So now we know that there are 5 edges into this pentagonal prism over here. Now we are going to obtain 5 vertical edges over here corresponding to this 5 edges of the base corresponding to this pentagonal prism. So here we have got the vertical edges as 2 1 2, 3 1 3, 4 1 4, 5 1 5 and 1 1 1 over here. The distance between the successive vertical edges, it will be equal to 40 millimeter, which will be equal to the edge length of the base of this pentagonal prism. So now we have been able to obtain the development of the uncut pentagonal prism over here. So now we have been provided with the information that this prism has been cut by an auxiliary inclined plane, which happens to be inclined at an angle of 45 degree with respect to the horizontal plane and perpendicular to the vertical plane. And this auxiliary inclined plane, it is going to bisect the axis of this prism. So where does axis of this prism lie? axis of this prism lies at this particular position over here. So O dash, it is the axis point of this pentagonal prism at the top face of the prism, whereas O1 dash happens to be the axis point available onto the base of this pentagonal prism. So height of axis happens to be 75 millimeter. So the midpoint of this axis will be lying at a height of 37.5 millimeter from the base. So once we mark this point onto the axis, that is the midpoint of the axis, now we observe that this auxiliary inclined plane or the cutting plane, it is going to pass through this midpoint of the axis, and this auxiliary inclined plane will be inclined at an angle of 45 degree with respect to the horizontal plane, and it will be perpendicular to the vertical plane. So now we observe that this auxiliary inclined plane inclined at an angle of 45 degree and passing through the midpoint of the axis of the pentagonal prism over here, this is going to intersect with all the 5 vertical edges of this pentagonal prism. So now we know that this portion of the pentagonal prism has been removed as this AIP has cut into this particular orientation. So now we are left behind with this portion of the pentagonal prism over here. So now corresponding to the remaining portion of the truncated prism, we are required to obtain the development of the lateral surfaces of the truncated prism over here. So the first point of intersection, let us obtain. So the first point of intersection will be point 11 dash, which is obtained onto the vertical edge 1 1 dash and 1 dash by virtue of intersection of this AIP with the vertical edge 1 1 dash and 1 dash over here. So the first point of intersection we have obtained as 11 dash over here. The second point of intersection obtained onto the vertical edge 2 1 dash and 2 dash happens to be point 12 dash over here. So as the cutting plane will be intersecting with this vertical edge 2 1 dash 2 dash, so this point of intersection 12 dash has been obtained over here. Next point of intersection happens to be point 13 dash. So as this AIP intersects with the vertical edge 3 1 dash and 3 dash, so this point of intersection which is obtained onto this vertical edge 3 1 dash 3 dash, it will be marked as point 13 dash over here. Next point of intersection is point 14 dash, which has been obtained by virtue of intersection of the vertical edge 4 1 dash 4 dash with this auxiliary inclined plane. And finally the last point of intersection, it is lying onto the vertical edge 5 1 dash and 5 dash over here. So we have named this point as 15 dash. So all the 5 points of intersection of this auxiliary inclined plane with different vertical edges of the pentagonal prism, they have been obtained over here. So now let us obtain the location of these 5 points of intersection into the development projection view. So we have already obtained the development of the uncut pentagonal prism over here. So now we are going to transfer all of these 5 points of intersection into the development projection view. And another thing we need to remember, all the vertical edges of the pentagonal prism as they are represented into the elevation projection view, they are representing true length of the vertical edges into the elevation projection view. So now what we have to do, from point 11 dash, we are going to draw a horizontal projector line. Now wherever this horizontal projector line which is originating from the point 11 dash, it is going to intersect with the vertical edge into the development projection view. Which vertical edge? 1 1 and 1 vertical edge of this pentagonal prism over here. So the point number 11 has been located at the start of the development. point number 11 has been obtained at the end of the developed surface over here onto the vertical edge 1, 1 and 1 over here. Now the second point of intersection, that is 12 dash. So point 12 dash happens to lie onto the vertical edge 2, 1 dash and 2 dash in the elevation projection view. So from this point 12 dash, once we draw a horizontal projector line, so wherever this horizontal projector line emerging from the point of intersection 12 dash, it is going to intersect with the vertical edge true length 2, 1, 2 over here into the development projection view over here. We are going to obtain the point 12 into the development projection view. Now the next point of intersection is 13 dash. So this point 13 dash happens to lie onto the vertical edge 3, 1 dash and 3 dash over here. So from point 13 dash, once we draw a horizontal projector line, let us obtain the point of intersection of this horizontal projector line with the vertical edge 3, 1, 3 true length into the development projection view. So onto this vertical projector line, we are going to find this point of intersection over here. So this point of intersection will be point 13. Next point of intersection is 14 dash into the elevation projection view, and this point 14 dash has been obtained onto the vertical edge 4, 1 dash and 4 dash over here. So from point 14 dash, if we draw a horizontal projector line into the development projection view, now wherever this horizontal projector line, it is going to intersect with true length of the vertical edge 4, 1 and 4 over here. So this point of intersection will be obtained as point 14. Last point of intersection happens to be point 15 dash. So point 15 dash, it is the point of intersection of the auxiliary inclined plane and the vertical edge 5, 1 dash and 5 dash. So from this point 15 dash, from the elevation projection view, if we draw a horizontal projector line, and wherever this horizontal projector line is going to intersect with the true length of the vertical edge 5, 1 and 5 into the development projection view over here, we obtain this point of intersection as point 15. So this way, all the 5 points of intersection of the AIP with the various vertical edges of the pentagonal prism, they have been located into the development projection view over here. So now we need to join different points of intersection alongside the different remainder portions of the vertical edges which are left behind after the intersection of this pentagonal prism by this AIP over here. So now we have been able to obtain the development of the lateral surface of the truncated pentagonal prism over here. So this way we have been able to obtain the development of the lateral surface of the truncated pentagonal prism over here. So now this is all for today. I hope that through this discussion you would have understood about the procedure to evaluate the front view orthographic projections of the sectioned pentagonal prism, top view projections of the pentagonal prism, and the development of the lateral surface of the truncated pentagonal prism over here. So we are going to continue with further discussion on development of lateral surfaces of the solids in the coming lectures. So thank you very much. Thanks a lot.